All right, welcome back. We're going to continue talking about the volume of cones, spheres, pyramids. And we ended off last video without doing examples 4 and 5. So here we go. A spherical tank containing oil has a diameter of 1.5 meters. Very important measurement right there. What is the volume to the nearest tenth? We need to know what shape we're working with, and we are working with a spherical tank. So I know that we're going to need the formula for the volume of a sphere, which is 4 over 3 pi r cubed. And we can go ahead and start finding our dimensions to put in. Now, if I have a diameter of 1.5, we're going to take that value, divide it by 2, and we are going to get our radius of 0.75 meters. 0.75 meters. And we're going to cube that value. So when I plug it in my calculator, we get 1.8 meters cubed as the volume of that tank to the nearest tenth. All right, 1 cubic meter, so this is part B now, is equal to 1,000 liters. And how many liters are in the tank? So when we did surface area, we had to convert. I believe there was a problem. We converted centimeters squared into meters squared, and it's going to be the same idea. So we're going to use this fact to set up our proportion. So 1 cubic meter is the same thing as meters cubed. Okay, and that's going to be equal to 1,000 liters. And the way we looked at doing this is matching the units up on the left and the right side. So we're trying to look for the amount of liters, which means I don't know how many liters we have to work with. Let's call it X. I do know from part A that we have 1.8 cubic meters to work with. So I have 3 out of the 4 parts in my proportion. We can cross multiply and divide now. So we're going to take the 2 numbers that are diagonal that we know, and we're going to multiply them together. So we're going to take 1.8 and multiply it by 1,000, and then we're going to divide by what's left over. So in this case 1, and that will point us to our answer. Okay, so if we do all of those calculations, X is going to be equal to 1,800 liters. So in this tank, there are 1,800 liters. Part C says 1 gallon contains 3.875 liters, so just about 4 liters. If you want an idea of how much a gallon is, it's pretty close to one of those 4-liter milk jugs that you buy at the grocery store. How many gallons does the tank hold to the nearest tenth? So we are told that 1 gallon is the same thing as 3.875 liters. We know how many liters this tank holds. We just did that in part B. We know this tank holds 1,800 liters. We don't know how many gallons that is. Okay, so by the same process we did last time, take the 2 numbers that are diagonal that you know, multiply them together, and I actually drew that arrow the wrong order. Let's go this way. Because what I then need to do is multiply by the number that I haven't used yet, so 3.875, and then I get my answer. So we're going to take 1, multiply by 1,800, and then divide it by 3.875. Hit enter. And to the nearest tenth, X is going to be equal to 464.5, so 464.5 gallons. Okay, so there's how much goes in that tank. So as you can see, 1.8 meters cubed, 1,800 liters, 464.5 gallons. Those are equivalent. We've just converted from one form to another. Just made them look a bit different. And the last one we are going to talk about today is number 5. Now I apologize, in your notes, the numbers in blue, so those radius of both those shapes, it got cut off when I did the printing. So the radius of the cone should be 2 inches, and the radius of the cylinder is 3.5. So if you look at this one, Mikhail is casting garden gnomes out of concrete. He wants to know how much concrete he will need to make 20 gnomes. He approximates the gnome as a series of similar shapes. The hat is a cone, the head is a hemisphere, and the body is a cylinder. What volume is needed to make 20 gnomes? Before we do that, we need to recognize what shapes we are working with. So we have cone, which we have a formula for. So the volume is 1/3 pi r squared times the height. We also have a cylinder, where the volume formula is pi r squared times the height, and the new one, a hemisphere. Now, the formula is going to be the exact same as it was for a regular sphere. We just are going to have to divide it by 2 at some point when we're doing this calculation. Hemisphere just means half a sphere. So 4/3 pi r cubed. And we'll deal with the division once we get the answer. So we can go ahead and start plugging in some numbers here. So 1/3 times pi. And we're looking at the cone, so the radius is going to be 2 inches. We'll square that. And the height is 6 inches. So the volume of that cone is 25.1 inches cubed. Okay, the cylinder is pi times the radius of that cylinder, which is 3.5. We'll square that value, and the height is 7. So the volume ends up being 269.4 inches cubed. And the hemisphere is 4/3 pi times the radius of the sphere. Now the radius of the sphere is identical to that of the cone because the cone is laid right on top of the sphere. So that radius is also 2 inches, and we will cube that value. So we are going to get 33.5. Now before we do anything else, we have yet to cut this sphere in half. So what that 33.5 represents is the volume of a full sphere. So let's divide it into 2 parts. And our volume becomes 16.8 inches cubed. So we have the volume of all 3 parts separately. And so let's figure out the total for 20 gnomes. So we're going to have to take the volume of all 3, add them together, and then multiply by 20. So 25.1 inches cubed plus 269.4 inches cubed plus 16.8 inches cubed. Add them, and then multiply by 20. And if you do that in total, we are going to need 6,226 inches cubed of concrete. I believe it's concrete we're working with. Yes, concrete to make 20 gnomes. And that brings us right to the end.